High-low. The high-low method is a straightforward technique used to separate mixed costs into fixed and variable components. It relies on the highest and lowest levels of activity and their corresponding costs. The first step in this method is to identify the activity levels with the highest and lowest costs. Then, the variable cost per unit is calculated by subtracting the cost at the lowest activity level from the cost of the highest activity level, and dividing the difference by the change in activity levels. This provides the variable cost per unit. Once the variable cost is determined, the fixed cost is calculated by subtracting the total variable cost at either the high or low activity level from the total cost at that level. The high-low method is beneficial due to its simplicity and speed, making it a popular choice for businesses that need quick estimates. However, it has limitations, such as being influenced by extreme values that may not be representative of normal business operations, which can lead to inaccuracies in cost estimation. Application and limitations of high-low. Although the high-low method is simple and useful for estimating costs in environments with fluctuating levels of activity, it has some drawbacks. One of the main criticisms is its reliance on only two data points, the highest and lowest activity levels, without considering the broader range of data. This limited data selection can lead to inaccurate cost estimates, particularly if the chosen high and low points are outliers or not representative of typical business activity. The method also assumes that costs behave in a linear fashion, which may not always be true. In reality, costs may exhibit step changes or may not be strictly linear, especially in industries with significant economies of scale or step-fixed costs. As a result, while the high-low method can be a useful starting point, businesses often need to supplement it with more sophisticated techniques, such as regression analysis or the use of more comprehensive data, to achieve more accurate and reliable cost estimates. Learning curves. The concept of the learning curve refers to the phenomenon where the cost or time to produce a unit of output decreases as the cumulative volume of production increases. This occurs because workers become more efficient at performing tasks as they gain experience and knowledge. The learning curve is typically expressed as a percentage, with the most common being a 90% learning curve, meaning that each time production doubles, the time or cost per unit falls to 90% of the previous level. The formula for calculating the learning curve is typically represented as, whereas the average time or cost per unit is the time or cost of the first unit, is the cumulative output, and is the learning rate. Learning curves are particularly useful in manufacturing and production environments, where repetitive tasks lead to efficiency gains. By forecasting future improvements in efficiency, companies can more accurately plan for costs, set pricing strategies, and manage resources. Factors affecting learning curves. While the learning curve effect can lead to significant cost savings over time, several factors affect its applicability and the rate at which learning occurs. For instance, the complexity of the task plays a significant role. More complex processes may experience slower learning rates compared to simple, repetitive tasks. The training and experience of workers also influence the speed at which efficiency gains are realized. Well-trained employees typically learn faster. The use of technology can either accelerate or hinder learning. For example, automation may reduce the potential for human learning but could still improve efficiency overall. Additionally, breaks in production, such as long downtime periods, can reset the learning process, as workers may need to relearn certain skills after a prolonged absence from the task. Companies should be aware of these variables when forecasting the benefits of the learning curve and apply appropriate adjustments to their cost and resource planning models.